Hi there, this is going to be how to build a micro 5.8 GHz FPV setup. So, first of all, starting with the parts list, we have the ready-made RC Pico wide V2 camera. This is a great little camera, high quality, I highly recommend it. While you're at ready-made RC, go ahead and pick up the micro FPV wiring harness. This is not necessary for this build, but it will make your life much easier. Also, buy a 5-volt step-up from Ready-Made RC. This is a great little micro step-up for these micro FPV setups, and it is perfect. It helps not only keep your voltage constant, but also filters your voltage. So if you're running a 1 battery setup, like on a microcopter, then you can take power straight from that 1 battery that you're using to run your motors and everything, and also run your FPV setup without getting lines. Then moving on, you'll have to go to Banggood. I highly recommend circular polarized antennas for 5.8 GHz. You can make linear polarized antennas, but it's easier just to use circular polarized. Here's a ultra lightweight 5.8 GHz right hand circular polarized antenna from Banggood. Then we're going to need the video transmitter itself. This is a 400 milliwatt Bosch cam video transmitter. It is TX5826. That is what you search on Banggood to find it. And then go on eBay or an electronic shop or anywhere else to get a little 4-position dip switch. This is also not crucial, but it will allow you to switch channels on the fly if you're flying with friends or find a channel that has interference. So now that we've taken everything out of the package, the first step is to solder on the dip switch onto the micro video transmitter. We're just going to solder this on to channel 1, channel 2, and channel 3. So to solder on this dip switch, I've bent one side of the pins flat and the other side is sticking straight down. There is an extra pin. As you can see, the pins line up right here, one from the side. Channel 1, channel 2, ground, and channel 3. So obviously the ground does not need to be connected. However, it will not affect the performance at all, and it will just add another point of contact for this dip switch so it's more solidly mounted. I'm going to go ahead and solder it. You could snip this pin off if you wanted to, but the more points of contact to relieve stress on the other points is a good idea. Therefore, because this FPV setup is going to be going through a lot of vibration and crashes, etc., so you don't want this thing falling apart or any of the solder joints failing under stress or vibration. Okay, so before we start soldering, I'm going to clean up the contacts. It's not necessary, but it's good practice. I'm just going to use some alcohol on a piece of paper towel. Any manufacturing oil or debris or contaminants might be on there, so this is just good practice to make nice, clean, strong solder joints. Also, we're going to pre-tin everything before we start soldering. It's not necessary in this scenario, but it's just good practice, so we're going to do it anyway. The only reason I'm using so much solder here is to simply prevent the stresses of vibration and crashes to break this dip switch off. If you wanted to, you could use a lot less solder. And this may be excessive, but I like my gear not to break while I'm flying, because nothing worse than a ruined flying day due to a single stupid soldering joint. So, next up, we're going to talk about the wiring harness. So here's the little wiring harness, and let me talk you guys through it. First of all, we have the power in, positive and negative. This could be either from a small little 1-cell, or it could be off the power off your flight controller or wherever. Next, we're going to take the positive from your power source. Make sure it's under 5 volts, very important, otherwise you'll burn up the step up. So the positive from your power source goes to the V in, ground goes to ground, and the voltage out is split between the video transmitter and the camera. The ground is also just split between the video transmitter and the camera. Video, in this case, is white, just goes straight from video transmitter to camera, nothing fancy there. In this case, since this video transmitter has no plug, we're just gonna go ahead and snip that off and solder it straight onto the video transmitter. So on the ready-made RC wiring harness, the connector that is facing the voltage step down, these are labeled when you buy it by these little labeling strips that say CAM and TX. I decided to take them off for ease of use. So the end that goes towards the video transmitter, we're going to snip that because we're just going to solder it straight on to our little 5.8 gigahertz video transmitter. Now, stripping little wires can be a big pain. There are 3 methods that I recommend. Method 1, if you have no tools at all, you could use scissors or a knife and carefully cut around the wire and pull off the insulation. That method's okay, but with wires this thin, it's very easy to cut right through the wire. You could use a pair of wire strippers, like this, but many of them don't go down small enough, so a solution is to open it up, put the wire into the smallest section that is available in the wire stripper, and push it down with your finger. Be careful not to cut yourself, because some of these are pretty sharp, and just pull up, and it should pop right off. Another method, not many people know about this method, but this is good for extremely fine and delicate wires, is to hold your wire in something like helping hands. These are very helpful. Then grab the end of the wire with your nail, just the very tip, heat up the wire with a lighter, and the insulation will melt. And as you're heating up the wire, make sure to be pulling on the insulation on the outside. And if you watch, just going to heat it up and it slips right off, and then you have a stripped wire, and you don't have to worry about breaking any of the little leads inside the wire. So my preferred method for stripping wires this thin is just to use the traditional wire stripper, with holding the wire down on the little notch with your thumb, pulling, and boom. Well, so as you see, we've run into a little conundrum. Stripped off too much wire. This happens a lot with these little wires. So a good thing to have on hand is ultrafine heat shrink, and you can just put it right over the wire that you stripped too far, and that can be your insulation. Works just the same as what would normally be there. Okay then, let's pre-tin all these wires and solder them onto our video transmitter. So after we've pre-tinned everything, pretty easy, just go ahead and solder it all up. On the board, VCC is power in, the 3.3 to 5 volts. Then we have ground and video. Perfect. So let's solder our ground to ground. Video to video. Well, we're going to actually cut this down because I don't like quite how long this is. We just need a little tiny bit. Perfect. So, video to video. And of course, VCC to power. This is the filtered 5 volt power coming out of the 5 volt step up. So, last but not least, we're going to take our FPV antenna, cut it to whatever length you want. Really doesn't matter. Some people say on the forums that it does, some people say that it doesn't. I personally haven't found it makes much of a difference. I prefer to have my antennas a little bit longer so I can have them out of the way, tie them down, add extra support, whatever. So I'm going to leave my antenna long. You can always shorten it in the future if you find that you need to. Lengthening antenna is not as easy. So first we're just going to gently strip around the coax shielding to expose the actual shielding material itself. Now here, to fray back the shielding, it is a very good idea to have a little pin or just a little sharp object. Here I'm just using the tip of a tweezer, and that makes it really easy to unbraid the shielding. See? Now we're going to make this into 2 approximately equal groupings and twist them together. Right. Make sure you have no little stray wires. It's always the little stray wires that get you that you don't see. Especially with working with wire this fine, it's really easy to miss a little wire and wonder why you blew up your little circuit. Then you want to strip a little bit off the center lead, which is the positive of the antenna. Tin everything, and we're simply going to solder it on middle to antenna and ground to ground. So yeah, let's tin it up and solder it on. So now all there's left to do is to hook up your camera. In this case, it's kind of weird because white is video off the video transmitter, but normally video is yellow. We're not going to use the audio off the camera. Black to black, red to red. Make sure your wiring harness looks good. Here I just bent the antenna up at a 90-degree angle. Now I'm going to use some hot glue to reinforce this connection right where the antenna is. Be careful not to cover too much of this metal heatsink because the video transmitter does get pretty warm during operation. And yeah, you can configure this however you want. I'm going to make this a little FPV backpack, and instead of running it off the power off a flight controller, I am going to run it straight off a 1-cell Lipo, just for ease of use and the easy ability to swap it to any aircraft that I want. Alrighty then, well, let's go grab the hot glue gun. So after powering on our little FPV setup and confirming that it works, we're going to reinforce the joint here. Be generous with the hot glue. Hot glue is your friend. Ideally it would be better to use epoxy because these video transmitters do get pretty hot. I'm going to be running these with very high airflow, and so hopefully that'll keep them cool enough to stop them from melting the hot glue. No guarantees. This is just what I do on mine. Like I said, if possible, epoxy is much preferred, but because this is supposed to be quick and easy and not too involved of a project, we're just going to go ahead and use hot glue. Also, on some of these little wires, just to provide a little bit of strain relief, we're going to throw some hot glue on there. And there you go. Ultra micro 5.8 GHz FPV setup. Hook up a 1-cell or hook it up straight to your flight controller. Either way, it's going to run just fine.